Good evening. I would like to explain the smart water tank monitoring system project we have done under module Internet of Things. So we have provided a solution to monitor the water tank used in household. So we have designed a dashboard. It's a local host website. So we have designed a dashboard. We use Node-RED flows to design a dashboard. So Node-RED is a virtual programming platform. So here's our introduction. We are Team Echo, and initially we have 7 tanks. So we made only one physical tank. So the user can log in here. Actually now it's already logged in tank 2. So you can see the tank 2 is actually it's a virtual tank. So in the virtual tank you can see water level is up to 96, 97 percentage, and the water flow rate, we can see water flow rate and temperature of the water. Also connection status of the tank, and the water pump whether it's on or off. We can on off manually by switching. Also there will be power cut schedule. Power cut schedule mean now if CEB provides any power cuts, so the date will be updated here. So I will show it to you now. I can show you now. Multiple user can log in here. So now we are logged into the tank 2. I would like to show you tank 1. The tank 1 username is tank 1 and the password is 1. So you can see now tank 1. So the similar to the tank 2. Okay, in the summary we can see that how many time the pumps used in a day. Now actually for today we haven't used any. So now 0 mean, so here it displays 0, so we haven't used any pump. So water pump power in HP horsepower 1.5. It's a detail of the pump used for the water tank, and the tank fully filled in the present day, that also 0, and the pump current rating it's a 8.5. Now I can show you water tank 6 for example. If we log into the water tank 6, so it shows that time pump used in a day 2 and water pump horsepower is 1. So water pump horsepower is 1 and the tank fully filled present day is 1, and the other details. So I can go to garden tech. So in the garden one we can see the past years of the details of the how much water was used in liters for each month, and the energy is used in kilowatt hour. So it's a unit. So now current water flow to the garden, also we can monitor the current water flow to the garden. So now we are actually looking at tank 6. So we can look at the garden and the monthly summary. We can look the for example, if I choose October, now we can look at the each date in October in 2013, how much water is used in liters, and for each date we can look at the monthly energy consumption in kilowatt hour. So we can look at the summary for month. Now I can switch to the, for example, March. So for March we can look at the summary, for it will change within a time. So we can look at the monthly water usage in March and the energy consumption. So for the summary of the month, for the March month, we can look water pump switch, how many time water pump is switch, it's 50, and water used in liters, and energy consumption in unit. So if we select the date, we can look at the date. Actually now for the we have import date up to 2015 to 2015 to 2013. So now the date is selected 2001. So I need to go. We have data. We have used the data for 2015 to 2023. So for example, now select 2019 for any date. So we can see how much in the date 2019 9 month 12. So how much time the pump is switched, and the water is used in liters, and energy consumption. Water pump use duration in minutes. So the monthly summary is over. So next part is the annual summary. Likewise, the monthly summary we can look at the annual summary. So if we switch any year 2022, so we can look at how much water is used and the annual energy consumption, and previously we saw that water pump is switch and tank fully filled. Also water used in liter for the year, and the water pump is used duration in our energy consumption. So and our it's about our teams and our services. So here's our email and website. So these are contribution of the group members. So now let's look at the some of the photos taken during the evaluation. So we used ESP32 as a microcontroller. So the ESP32 is connected to the MQTT server. So it will sense the tank. Now tank is actually here. This is our tank. So we have attached a ultrasonic sensor to the water to measure the height of the water and subtract it from the tank height, so we can get the level of the water actually. So this is the our tank setup, and this is the water resource. Actually this is like well, this is like well, and this part is, this is the tank. So if the, no, if the water level is reduced to zero, so automatically water will fill from the water resource. So these are the some of the parts. Now we use, now Arduino we use to just power up the 5 volt sensors, and we have relay modules to power on and off the pump, water pump. And here's the water flow sensor to measure the water flow speed. So here's the video. Now when the tank is empty, the water will automatically will fill from the water resource like well. So when the water is filled, now you can see that water level is increasing. So when the water level is filled to the 85 percentage, so automatically it will stop. The relay module will stop because the ultrasonic sensor will sense the distance. So when 85 percentage of the water will fill, so stop the pump.